Assalamu alaikum. Today we are going to learn about mesh analysis, which is the procedure for analyzing circuits. So mesh analysis is a technique for solving circuits using mesh currents as circuit variables. Mesh analysis applies KVL to find unknown currents. So at first, let's try to understand what is a mesh. In circuit analysis, a mesh is a special type of loop in a circuit. It is a closed path that doesn't enclose any other loops within itself. For example, if we look at the circuit below, we can see that there are three meshes in it. We can call this mesh number 1, we can call this mesh number 2, and we can call this mesh number 3. Now, the second thing that we need to understand is what is KVL. So, Kirchhoff's voltage law, or KVL, states that the algebraic sum of all voltages around a closed path or loop is 0. So what does that mean? That basically means that in a loop, the sum of voltage rises is equal to the sum of voltage drops. For example, if we look at the given circuit, then if we apply KVL to it, then we can write that minus V1 plus V2 plus V3 minus V5 plus minus V4 plus V5 equals 0. So if we apply KVL to this loop, we can write this equation. So as you can see from the equation, it indicates that the sum of voltage rises is equal to the sum of voltage drops. Now, if we come back to our topic, we were studying mesh analysis. So now that we understand KVL and we understand what is a mesh, we will be easily able to understand mesh analysis. So let's try to understand what are the steps of mesh analysis, or how to solve a circuit using mesh analysis. So here there are three main steps. The first step is to apply mesh currents I1, I2, IN to n meshes. How many number of meshes there may be? Then the second step is to apply KVL to those n meshes. We use Ohm's law to express voltage in terms of mesh currents. Then the third step is to solve those resulting n simultaneous equations that we found in step 2 to get the mesh currents. So now, if we try to solve a mathematical problem using this mesh analysis, so if we look at our circuit, we can see that there are two voltage sources in our circuit, which one of them is 15 volt and the other is 10 volt, and there are 4 resistors in our circuit of 5 ohms, 6 ohms, 4 ohms, and 10 ohms. Now, if we regard the current in this branch as I1, and then if we regard the current in this branch as I2 and in this branch as I3. Now we are going to define the mesh currents in the two present meshes in the circuit. So let us name the mesh current of the first mesh as small I1 and the mesh current in the second mesh as small I2. Now let us apply KVL at mesh 1. So if we apply KVL at mesh 1, we can write that minus 15 plus 5 I1 plus 10 I1. Now we have to write minus 10 I2 because the mesh current I2 is opposite to the direction of mesh current I1 going through resistor 10. Then we can write plus 10 equals 0. Now if we calculate it, we get 15 I1 minus 10 I2 is equals 5. So we can keep that as equation 1. Now let us apply KVL at mesh 2. So applying KVL at mesh 2, we get 6 I2 plus 4 I2 plus 10 I2 minus 10 I1. We are subtracting I1 here because I1 is opposite to the direction of I2. Then minus 10 is equals 0. So if we calculate it, we get minus 10 I1 plus 20 I2 is equals 10. So that is our equation 2. Now we are going to solve these two equations to find out the mesh currents I1 and I2. So we can simplify equation 1 as 3I1 minus 2I2 is equals 1. Then we can simplify our equation 2 as minus I1 plus 2I2 is equals 1. Now we can solve these two simplified equations, equation 3 and equation 4. So from equation 4, we can write that from equation 4, we can write that I1 is equals 2I2 minus 1. Now, in equation 3, we can substitute this value of I1. So substituting this value of I2, we get this 3 into 2I2 minus 1 minus 2I2 equals 1. Now, if we calculate this, we get 6I2. We get 6I2 minus 3 minus 2I2 is equals 1. Or we get 4I2 is equals 4. So from here, we get I2 is equals 1. So we have found out the value of mesh current I2, and it is 1 ampere. Now, if we input this value in equation 4, we get I1 is equals also 1 ampere. We also get that I1 is also 1 ampere. Now, if we try to find out the branch currents, capital I1, capital I2, and capital I3, we get capital I1 is basically equal to mesh current I1. So it will be equal to 1 ampere. Then capital I2, if we look at our circuit, capital I2 is equal to mesh current I2. So that will also be simply 1 ampere. Then if we try to find out branch current I3, you can see that branch current I3 is in the direction of I1 and opposite to the direction of I2. So I3 will actually be mesh current I1 minus mesh current I2. So if we calculate that, we get I3 is equals 0. So actually no current flows in that branch through I3. So this is it. Our circuit is solved. So as we can see here, we can easily apply mesh analysis to solve circuits